Okay, student, let's continue the last part of the lecture number 6 called lecture 6C. In this lecture, or in this portion, basically I have to cover one more method. That method is called secant method to find the root of nonlinear equation. Okay, this is called secant method. Okay, this method is important, and this is the third method in a sequence. Apart from that, we have to discuss another method. So this method is a key point to discuss the fourth method as well. So kindly focus more on this working. So I'm not, obviously I have to save time. I have to cover both methods in this slide. So to that, to in this portion, in fact, not in slide. So whole story is clear to you. There is some equation nonlinear whose root we cannot find. We need to apply different approach. In bisection we have a interval halving strategy. In Newton-Raphson we have a tangent that intersects the intercept. We claim that as a root and we try to refine it such that we will reach to the stopping criteria that has been mentioned in the bisection method, which is also hold for Newton-Raphson. So now that is a third method called secant. In this case, the same thing has happened. Like we have some equation given, f of x, and whose root exists. Okay, and we need to find that root. Let's say xr is the root that belongs to the domain, such that if you put the xr in the function, you will get exactly zero answer. Okay, the root must exist. So how the secant method tries to find the root. So let me draw the diagram again, which is very similar, which we have done many times already. So the diagram that we have to draw is something like that. And then we will cover the derivation part. So first I have to explain again in the graphical way, but this time little bit not so going so much detail because it's very simple method and it has a very similarity with the Newton-Raphson, but the strategy is totally different. And you will notice that how easily you can develop new methods. So this is the XR, okay, and this is the any non-linear function transcendental polynomial given to you. So you just plot that function. So to start that method, you need two starting points, okay, x0 and x1 or any starting point. So you can select those 2 points. Start with 2 points, okay. Just in Newton-Raphson, you just need 1 point x0. Here we need 2 points, x0, x1, and they both needs to be belong to the domain of the function. So for example, you select x0 here and x1 on this side. Okay, so this is the x0 and x1. So similarly, you can find 2 points on the curve on the function. This one, which having coordinate x0, f of x0, and x1, f of x1. Okay, so these are the 2 points. So we all know what was the strategy of the secant method. We can have some idea from its name as well. We know that the secant is also a line just like a tangent, but the property is that it may intersect or touch the point more than 1 point. Okay, so it may, for example, in case of a circle, if you remember, if there is a line that cuts the surface or a plane in a two, we used to call it chord. But or basically this is a line and it is touching the or cutting the circle at two different points. So we can, in general, we can call it as a secant as well. Similarly, secant is just a line that cuts the plane at two different points. So at least it can cut many points as well. So it's not like a tangent. In tangent it has to touch only at a 1 point, but here it can cut the surface as well. Okay, so it is cutting the surface. So I have selected 2 points, and I will try to draw a secant. Secant is a line that cuts, so I am making it pass through these 2 points, and obviously if I extend it to certain geometrical practice, then it will be intersecting somewhere on the x-axis as well. So I selected x0, x1 randomly. I mean, here there is no condition of derivative, but it conditions suggest that root must exist and x0 and x1 are defined. So obviously we are dealing with the domain. I already told it belongs to the domain. then obviously f of x naught and x1 is defined. So what I did, I selected 2 points and draw a secant on it. A secant must pass through the 2 points, so it's passing through it and it intersects the x-axis at a certain point. So we get x naught, x1, and the last one is for us is x. So when I use x naught, x1, I will get x2. Okay, and what is x2? If this is the secant, let's call it secant 1. So this is the secant, then x2 is the x-intercept of the secant 1. x2 is the x-intercept of secant s1. Okay, sorry. So this is the one condition. So now we have this situation, and in this situation we have a secant s1 defined there. So okay, so what secant method does? Secant method claim that the intercept of the secant could be regarded as a root of the equation. Although we can see that this x2 is not close to xr, there is some error, but this logic based on the selection of x naught and x1 can guarantee this thing as well. And it is not necessary that x naught, x1 will be on a one side. If x naught is there, x1 could be selected here, or both x naught, x1 could be there as well. If this is x naught, then this could be x1 as well. So there is no fixed root. You just need to select 2 points, use those points to draw a secant and find the intercept of the secant. And once you got the intercept of the secant, then what you have to do, you have to draw another secant. But how? Like this one. So if you get x naught, x1, you get x2. So if I write down what you have done, you have used x naught and x1 to get x2. Okay, now what you have to do, in your choice, what we can do, we have to discard x naught and x1, sorry, out of x naught, x1 1 point. So I am just for maintaining a sequence, I am discarding x naught. So I discard, so whatever the point left is x1 and x2. So what I have to do now, using x1 and x2, I have to find another secant intercept. So how I can do that? This is the x1 here, and this is the x2. So this would be a point somewhere there, having coordinate x2, f of x2. And what I have to do, using these 2 points, I have to draw a line which has to be a secant. So this is the secant. Let's call it S2, because line has to touch the 2 points. So it can intersect this way. This line is cutting at this point x2 and this point x1 and this. So I can see that this line also has an intercept, and let's call it x3. So what I did, I use x1, x2 to get x3, which is the x-intercept, x-intercept of S2, that is secant number 2. So you can get the idea. Can we claim that x3 is relatively close to xr? Yes, we can say that based on this geometry, it is very close to xr. Does this logic make sense? Yes. In this case, if we continue to like that, we ultimately reach to the root, close to the root, because this will guarantee that may exist. Because what we are doing, we are this kind of Newton-Raphson method, but here the method to draw a line or find the intercept is not like only 1 point tangent. It is depending on the point information. So it is much better strategy. So we will get this point. Similarly, now what should I discard? When I use x naught, x1, I got x2. So in next iteration, I discarded x naught and use x1, x2. Now x1, x2 is there. I have got x3, which is this point, but I think it's still some error. I need to do one more iteration. So what should I do in sequence? I will discard the lowest index. So I discarded x1, and whatever I got is x2, x3, and using x2, x3, I have to find another point. Obviously, that would be x4. I'm not drawing it, but you have got the idea. So I have to use x2 and this point x3, and I have to draw a tangent there. So in this way, if we continue, ultimately this method guarantees that you will reach to the root. If we continue, so we will reach very close to the root. Okay, so I don't know how many points I need, but this is the iteration. So you all know why it's called secant, because we try to approximate our root by the intercept of the secant. This is the strategy. So instead of tangent, we are drawing secant. As for secant, we need 2 points. So to start this method, we need 2 points. And the sequence is quite simple. Start with x0, x1, get x2, discard x0, use x1, x2, get x3, discard x1, use x2, x3, get x4, discard x2, and so on. There is it is sequential. Just in indexing, it is sequential. You are always discarding the lowest index. So if it is x0, x1, x2, the lowest index is x1. You are just selecting and continue. This is the one way of this iteration. Okay, so this is how the secant work in a geometrical sense, and I will give you the derivation in the algebraic sense as well. But for the time being, think about it. Is there, if we have this strategy, does this method has any issue in it or some problem that may arise in the later stage? Think about it. Okay, so just for your thought, think about it, that whether you will end up with some problem or not. So because the idea of the secant is also relying on the concept that root may be approximated by root may be approximated the intercept of by the intercept of what? By the intercept of secant. This is the whole strategy of this method. So this is what we have explained. Let's drive its geometrical form. So when you have started to, if we have to do this iteration, I need 2 points at any iteration. Okay. So if I'm here, I x0, x1, I read it required to obtain x2. If I need x3, I need x1, x2. I need 2 points. So let's call those two consecutive points by the following indexes. Okay. Yeah, we can do it here. Or maybe let we have 2 points. Let xi f of xi and xi plus 1 comma f of xi plus 1 are 2 points known to us. Okay, these are the points that are known to us, which means that, for example, if when I started with x0, x1, so this is x0, this is x1, because I got value 0. So if I am in a second iteration, I need x1, x2, then this becomes x1, this is x2, two consecutive indexes. Okay, so these are I'm not showing for a specific index. I'm just making the derivation for generally for any two consecutive point to generate the third point. So now the point that we have to generate is xi plus 2, because x0, x1 gives x2, so xi plus 1 gives xi plus 2, such that xi plus 2 is the x inter x intercept of these 2 points. Okay, so these are the x-intercept of these 2 point xi plus 2. So how do we got this point? Because secant method is relying on the strategy that that point could be regarded as the as a root of the equation. Okay, so let me make some space here, and then we will continue our topic. Okay, so let's drive its algebraic representation. Same reason, we will not use this geometrical concept. It's just understanding the concept. When we are solving something equation, we should know what that method is doing. So what we are doing in secant, we selecting 2 points, using those 2 point, finding a secant equation, and then finding its x-intercept. And once the intercept is known to us, then what we are doing, we are just replacing it with the sequence. So there is a sequence that's going on, and this method claims that if you repeat this process infinitely, you ultimately reach to the root, and that is xr. Okay, provided that one point does not arrive. So I have not shown you that point. Okay, so let's see what was that point. Here, student, keep in mind that if derivative at any point x0 or x1 is 0, no issue. There is no issue. Okay. However, derivative at x naught and x1 at a time should not be zero, but that's a different thing. So keep in mind that x naught and x1 or any point, two consecutive point, if derivative is zero at any of this point, no issue. There is no issue, but in tangent, that would be a biggest problem. So in this method, there is the advantage. If the slope goes to zero, any of the point does not matter, not a problem for us. Okay. So this is one thing. So let's drive it algebraically. So we have 2 points, a very simple derivation. We have 2 points, xi, f of xi. I prefer to write it like that, but it could be a yi as well. And xi plus 1. Plus 1 means consecutive point. If it whatever with the index this has, this point is just after it, plus 1, comma f of xi plus 1. Okay. So now what we have to do, we have to compute we have to compute the strategy algebraic. So what we have to do first, I have to find the equation of the secant at any ith index. So how to find the equation of us in index, secant, sorry, not index, secant is very quite simple. I have given 2 points, so we know that we have to use 2 point formulation. Okay. So 2 point formulation, because we have 2 points, so we can apply 2 point formulation. So we know that the formula for 2 point form, it is very simple. 2 point form, because secant is a straight line and I need the equation of this line. So these 2 points also lies, although the line is passing through this curve, but this also lies on the, these points lies on the line as well, which is given to us. So we can apply this 2 point form to get the equation of a line, which is also the secant in our case. Okay, so these 2 points. So how I can do that? Obviously, you all are familiar with it. So it has different representation. I am using 2 point form, I plus 1 minus f of xi divided by xi plus 1 minus xi equal to any point on this line f of x minus same thing standard what I did in the in the Newton-Raphson as well. Although the line is there, but we are saying that this line is very close to this curve, so we can have the value of this line along this curve as well. Whatever the value of this curve can be approximated with this line value as well. So instead of putting the y here or the value of here, I'm saying f of x. Although f of x lies there, but we are approximating. So we are saying that they are same. So this thing I can use in 2.5, I can use any of it. So I'm using this point just to have a symmetry. Okay. Similarly, X could be any point along this line, but it is very close to this equation. So it is very close to the root as well. So this minus X of I. So if I look this equation carefully, all these points are known to me. So I'm just keeping it here or moving it on any side. The point is that if I want, this is the equation of any secant. I have not drawn this separately, but you can understand if this is the xi, this is xi plus 1, then I need only 2 points. And if I continue this line, I will get this. If this is the equation of a line of a secant. But I know that this secant will intersect somewhere at the x-axis. And whenever it intersect, we are claiming that intercept as a root of this equation. This is the essence of this talk. So in secant method, we claim the root of the secant, intercept of the secant as a root. So this means that if this is the equation of the secant at x-intercept, that is this point will become xi plus 2, because we said that xi plus 2 is the x-intercept. So this will become the x-intercept. Then at this point, f of xi plus 2, this goes to 0, because x-intercept is claimed to be equal to the root of the function. So if it is equal to the root of the function, then this must goes to 0. However, we don't know it, where is the root, but we are approximating it. So at x-intercept, x-intercept, that is x equal to xi plus 2. So this point could we call it xi plus 2. Although this is related to x2 based on x0, x1, but this is the point. So at this the equation, I'm writing this term first. So I will get f of xi plus 2 f of xi divided by xi plus 2 intercept minus xi. I have wrote down this term first and then I'm writing this term because there is no unknown in it. So it is convenient to keep it on our left right hand side. These all quantities that I'm writing at the moment from there to here are known. This is not unknown. The only thing which is unknown is this point xi plus 2. Rest everything is known. Okay, so intercept at the condition of the intercept, this will be the form of the equation, but we know that because this intercept is also the root, this is why this term goes to 0. This term does not exist. Okay, at x-intercept this term goes to 0 because we are claiming it to the root. Agar root hai to it must be equal to 0 in this case. Now xi is known, f of xi is known, all other quantities are known. The only thing left is xi plus 2. We have to solve for xi plus 2. Okay, so how we can do that? Let's reciprocal this term, that make it up, and this term breaking it down. So this will be, you can solve it other ways as well. You can multiply and do it. It does not matter. At the end, final answer is same. I'm just reciprocaling. Okay. So this term numerator goes up, denominator comes down. Oh, sorry. Denominator goes up, numerator comes down. It is other way around. And this to maintain the equality, this has to go up, and this has to come down. So it is up to you. How do you simplify? I am not restricting it. The final form is only important. Okay. Now if you multiply this string here and then take out this term, so you will get some this kind of representation. This is equal to xi minus f of xi plus 1, not bracket here, bracket would be here, divided by f of xi plus 1 minus f of xi. Okay, so you just need to simplify. So what I have to do next, we can leave it like that as well. This is also the secant method, but let's simplify it to have a representation as we have learned in the book or in a text. So what I'm doing here, I'm just taking the LCM. So if I took out the LCM, then this term will multiplying to this whole term. Okay, so in the next slide, just simplification, although the final form is only important for us. So this will become xi into f of xi plus 1 minus f of xi minus f of x, I think I, yes, f of xi into xi plus 1 minus xi. And this whole is going to divided by f of xi plus 1 minus f of xi. Okay, so if I multiply this term, so it is just a simplification, although you can do it directly as well. So this xi into this term, I will get xi f of xi plus 1 minus xi f of xi, this term xi plus 1 f of xi. These I and I plus 1 are in subscript. This minus into minus plus xi into f of xi, and whole divided by, sorry, whole divided by f of xi plus 1 into f of xi. Okay, if there is something cancel out, do it like this one. For example, x minus f of xi, and this is going to be cancel out. So whatever left is I plus 2 xi f of xi plus 1 minus xi plus 1 subscript f of xi divided by f of xi plus 1 minus f of xi. So this is the formula for secant method. So what is doing? It is just taking the, and to use this formula, I need 2 points, xi and xi plus 1 given. Okay. So use this point, I need this two. So what I have to do, if I have these 2 points, I will put them, I will get xi plus 2, and then I will discard xi, I will use xi plus 1 and xi plus 2 to get xi plus 3 and so on. So for what indices these are? These are for I equal to 0, 1, 2, 3 and so on. So if I is 0, you will see that we will get exactly the same formula that I have explained for this geometrical configuration at the first time, x0, x1, x2. And when I have I equal to 1, that is second iteration in this indices, so I will get 1 plus 3 x3, x1 f of x2 minus x2 f of x1 divided by f of x2 minus f of x. Okay, this is the secant formula. So if you continue to find the intercept, which is the intercept of the secant, you will get a root ultimately. This is what the method is called, secant iterative method. Similarly, you can call it Newton iterative method as well, Newton-Raphson iterative method. This is iterative method called secant. Okay, keep in mind that it will not give you, it give you one answer, one attempt. You have to refine yourself. You will start from any two initial guess, x0, x1. Yeah. In fact, I should write it down like that, x0, x1 given. You cannot start this scheme unless until x0, x1 is given to you, or you can select yourself. Just you need 2 points to start this method. Okay, this is the method. But I said that during the derivation, there is some issue in this method. The certain issue is that we need only 2 points to start this method. So if I start this method by selecting 2 points, then there is a high likely chance that I will select 2 points like that. For example, this is the other example, drawback. You can call it drawback. And this drawback is basically rectified in our last method, that is a fourth method, which we'll discuss in the same lecture, drawback. So for example, this is the any any function and you want to find its root. Okay, so root is there. There is no problem with the root of this function. Root exists and you want to apply secant method. And you have learned that in order to apply the secant method, we need only 2 points. So you, for example, you selected 2 points like that. This is your x0 and then this is your x1. Perfectly fine. So you will get a point on this curve and then you will get a point on this curve. I hope you have seen the problem. And this and two, and you also know the coordinates x0, f of x0, x1, f of x1. So far everything is okay. But as soon as you draw the tangent, sorry, secant. So as soon as you draw the secant, which is passing through these 2 points and cutting the function, you notice that that tangent is going, or that secant is going parallel to the x-axis, just like the Newton-Raphson method issue. So, and this method relies on the concept that secant has to intersect the x-axis. So in this case, because the heights of these two functions are same, f of x1 and f of x0 are same, or any two consecutive point is not necessary at the beginning. It could happen any 2 points. If the heights are the same, the value of the functions are the same in magnitude, then this problem may arise. Although root exists, but this method fails to converge because this is the secant and secant is not going to intersect the x-axis. So method fails. This is the drawback of the secant method. So keep in mind that whenever you want to apply this scheme, so let's see that whether this issue, geometrical issue, is also highlighted in the algebraic formula or not. So if we look that, yes, that is highlighted as well. Because what this scheme is saying, if you want to apply the secant scheme, you have to ensure that denominator should not goes to 0. And the denominator can only goes to 0 when f of xi plus 1 minus f of xi are same. For example, 2, 2, 4, 4. And this is only happen when the function has the same height at two different points. So for any 2 points xi, f of xi, comma xi plus 1, comma f of xi plus 1, we have to make sure derivative 0 is not the condition. Keep in mind, derivative has nothing to do with the secant. We have to make sure f of xi is not equal to f of xi plus 1. Okay, from the beginning or in between, we have to make sure. If by mistake this happens, then your method fails to converge, else it will fail to converge. Again, I do not need to explain the word converge. Converge means that we will repeat this process so that we will reach to the close to the root. So it will not reach to the root because diverge is going to infinite. So this method fails. So this method has a drawback. So this is the formula for secant method iterative. You need two starting points to start this scheme, and then you have to just move x0 x1 gives x2. Then you have to discard x0. You have to use x1 x2 to get x3. You discard x2, you get x2 x3 to get x4, and so on. This will continue this formulation. But make sure that at any point of iteration, denominator should not goes to 0. That is this one. So this, if denominator goes to 0 algebraically, this is exactly the same situation which is in geometrically explained here, that the y values at any 2 points xi or xi plus 1 are the same. That's why it goes to the 0. Okay, so this is the condition. I hope you understand. The other method that we have to discuss, obviously there is no derivation for this method. Although we can do derivation, but it's not necessary because formula is the same as we have derived here. But if we impose a one condition on it, then we can have a very good rectification for this method. Okay, so what was that method is, this is the last method for the iterative scheme for finding the root, and we call it false position method, or sometimes we also call it Regula Falsi method. It is also the method of a category of secant method or a line search method, in which we try draw a line to find intercept and claim that intercept as a root. But this method I'm not going to explain separately. It is the same method as of secant, only this method ensures that this situation never arises. And this difference is very simple. So here what we are doing in a secant, we are just following sequence blindly, x0 x1, then x2, then discard x0, select x1 x2, discard x1, and so on and so on. This is way we have to make sure denominator don't go to 0. If it goes to 0, we have to start again. So this is the problem. So we do a very simple strategy. We have a same formulation, same same formulation as of secant, that is two points are required to start the algorithm to get the values like this one. Okay, this is the same formula that I'm using. Xi, f of xi minus xi plus 1, f of xi, sorry, xi plus 1 होगा. This is alternate होता है. If it is xi, then it will be xi plus 1. So this is xi, then it will be xi only. Okay, and divided by whatever be the given to us. This is xi, f of xi plus 1 minus f of xi. Same, you need to x0, x1 to start, and Okay, but here the condition is different. In the secant, we have a condition that these two are not equal at any time. We have to manually make sure that if it has happened, then we have to start again. But in the false position method or regular falsi method, the situation is different. What we have to do, we have to ensure this condition, and this is already we have discussed. It is nothing new. For any two consecutive points, f of xi into f of xi plus 1 should be less than 0. Okay, you remember this condition? I explained this in the bracketing of the root strategy. So this method make try to ensure this thing. What does this means? This means that you can select any 2 points, but you have to make sure that this condition hold. That is f of xi and f of xi plus multiply, they should be less than 0. That is negative. It has to remain negative. This is only possible when if f of xi is positive, then f of xi plus 1 is negative. Then in this case, it will be less than. Magnitude is not a concern, but sign is important. Or if it is negative, then this has to be positive. So if this is happening, then in either of this case, we will have less than 0 condition. Okay. So this is what we call it. Uh, the condition for the regular false and secant. So we just have to ensure that this denominator, what question is why we have this condition? Because this will ensures that this is not going to be 0 at any place. Okay, for example, if let's say f of xi, just for example, okay, for example, if f of xi at certain point is 2 and f of xi plus 1 is also 2, so we know that if I put this in a 2 in a denominator, if I put 2 minus 2, so I will get 0 in the denominator. So this means this method fails. But because in this case we cannot ensure this condition, because we need to have a different sign. So for example, if I have ensured this condition and I'm using xi and xi plus 1, then if it is 2, then this must be minus 2. Or if it is minus 2, then this must be plus 2. It has to be opposite sign. I'm discussing the ideal case where the magnitude is same, but sign is also needs to. What will happen in this case? For example, this is minus and this is plus. So we know that this has to be plus. So I have to put this plus 2 here, which is already there. And then this is the minus of the formula. And then this is the negative 2. So I have to put minus 2 because f of xi is minus 2. So this minus into minus will become positive, and then we will have a 4 there. It was not going to be 0 in this case. So what we have to do, we have to make sure that f of xi plus 1 and f of xi, if we multiply together, they have a sign less than 0, which means that they have negative, which means that they has to has opposite sign. Or you can do other way around. Or if it is, if for example this is positive, okay, and this is negative, negative 2. So what should you do? You should put minus 2 there. Now let me write down this case here. I'm not writing the complete equation, but I'm just telling the concept. So here, this is equal to minus 2. So this is going to be minus 2 for certain case. I'm just giving the idea. Minus, I'm just showing that it is never going to be 0. So f of xi is positive 2, so it will be positive 2. Now due to the opposite sign, that become minus 4. It's not going to be 0 in this case. So if we ensure this condition in a secant method, that is start with any 2 points by ensuring this condition as well, okay, and then continue. Now we cannot discard randomly. Before that, what we are doing, if we have in secant, what we are doing, if we have x0 x1, we compute x2 and we are discarding x0 without any decision, and then x1 x2, we got x3, then we are discarding the lower index x1, and in this way we are continuing to find the root. But there is a chance that we will break down our algorithm. But if you want to apply the false position, which is kind of a secant method, then what will happen, that we, if we have x0 x1, and based on that I have got x2, then I cannot just discard x0. I have to look this condition. I have to choose the 2 points. I have to look for this condition whether f of x naught, f of x2 is less than 0, or f of x1, f of x2 is less than 0. Obviously one thing happens. So if this is happening, for example, so the next point, next iteration point, if this happens, for example, then the next iterative point is x2, x0 and x2 in order to get x3, because I need 2 point. Because second method I need 2 point, but I have to ensure this condition as well, that if one is positive, function is positive on x naught, then negative on x2, or other way around. Similarly, if this condition, keep in mind only one thing happen. So if I have to move to second iteration, then if this is not happening, then this will happen definitely. So in this case, I will use, or I will use x1, x2 to get x3. It depends. Okay. So so it is just like a secant method computation wise. The only thing is that there is one check and balance increased. We cannot just discard in sequential. We have to make sure that this condition hold. In this way we can swap as well, or we can have a wrong position, a false position. So that's why this method is considered to be a false position sometimes in the text. Okay, so it is just like a secant method. I'm not going to explain it separately. When we solve example, I will just explain that how you have to perform the calculation. Okay, so let's end the lecture here today. And we have covered all four methods, iterative methods for finding the equation of a nonlinear equation. In the live session and other assignments, I will show you the working strategy on a data, how we can do that, and then we will discuss the application problem accordingly. Okay, student, thank you for your time.